Okay, day 7 is properties of linear relationships. This is a huge focus for Math 10. So, in terms of studying relations, there's all types of different relations, but for Math 10, for the most part, it's linear. Please just look at the root word of this. I mean, what word is embedded in there? It's a straight line. And then you're going to get questions on your exam. Is it a linear relation? Is it a linear relation? So how do you answer that question? So recall from the day 1 notes, when we were talking about getting a car rental, it costs $20 for every 100 kilometers that you drive. So this, I believe, would be a discrete relationship because you only have values for every 100 kilometers. So I don't think you'd connect this one. But being connected doesn't answer the question if it's linear or not. To answer the question whether it's linear or not, you have to look for this. A constant change in the independent variable. So a constant change in x results in a constant change in the y. So right here we can see that the delta x is 100 positive. It's going up by 100. And the delta y is a positive 20. Every time you go up by 100 on the x, you go up by 20 on the y. So it's really nice when you see it in a table of values. It's a little bit harder to notice it in the ordered pairs, but if you're clever, you can spot the patterns. Look at only the first coordinate, 0, 100, 200, 300, 400. You can see that the x's are going up by 100. Now look at the y coordinate only, 60, 80, 100. So you're looking for patterns in each coordinate, but look at them separately. Look at the x's separately. Look at the y's separately. So look at delta x, look at delta y. But do it separately. Don't start thinking like, okay, maybe the 0 goes to the 80. Like x doesn't go to the y. It doesn't work that way. X's are with x's, y's are with y's. And then what that would look like on a graph is this sort of step function where you go up 100, that's the delta x, and you go up y, that's the delta y. Up or over delta x, up delta y. Over delta x, up delta y. It looks like a ladder or a step. Looks like steps. Pardon me, looks like steps. Like a staircase. And that will guarantee a straight line. The staircase. You guys feel pretty confident in that? You could identify if a relationship is linear? That's all you have to do. Just look at the pattern. Okay. Flip the page. This formula here is delta y divided by delta x. It solves for the rate of change. It's also known as slope. Especially if you're taking Science 10, you know this. I would put a big star here and put include units. Because it's a rate of change. Well, what's changing? Well, in this example, it's dollars per kilometer. Definitely use the units to help you. So this would be read as dollars per kilometer. And then here is how you read it to yourself. The rate of change is 20 cents per kilometer. That is, for each additional kilometer, the rental cost increases by 20 cents. That would be if this was a continuous relation. Earlier I said I think it might be discrete because you only have information about every 100 kilometers. Every 100 kilometers. But if you take a look at this little paragraph, it's saying that now you could charge for whatever kilometers because you know it's 20 cents for every kilometer. That's if you make this connected. And then we generate an equation for this. To generate the equation, you have to have a clear understanding of this relationship, y equals mx plus b. So y is the dependent variable. In our case, it was the cost. It depends how much you drive. So which one's the independent variable? The x, which is in this case distance. Most often, you have the y variable, the dependent variable on the left alone. And then you have the equation on the right. It's not the entire equation that's independent. It's only the specific variable that's independent. 0.2 is 0.2. That's a constant value. 60. 60, 60. He knows who he is. He never changes. It's just 60. He's constant. But it's d that could change. You could have different amount of distances driven, and that will result in different amounts of cost. The m value is the letter that we give for slope, the rate of change. You will have this vocabulary word etched into your brain hopefully by the end of grade 10. Slope, rate of change. It means the same thing. So this is a huge vocabulary thing, and the formula is delta y over delta x, or in other words, it's the rise divided by the run. That whiteboard, you gotta know it. If you're studying, that would be right on the list of most important things to study. And the very last thing that we need to talk about is this b value. This is the initial amount. The initial amount for this example was the flat rate. You can see here, I haven't driven anywhere. My distance is 0, but I still have to pay 60 bucks. That's like you walk into the store, you haven't even gone anywhere in the car, you're like, well, you got to give me 60 bucks up front. Here's 60 bucks. Okay, now you can have the car. And every 100 kilometers that you drive, you're going to have to give me an extra 20 bucks. So that 60 is called the initial amount. And just a hint, this is also the y. This b value is also the y-intercept. So it'll live on the y-axis. It's 0, comma b. The initial value is when x is 0. It's the y-intercept. So I'll give you guys a second to get caught up. Okay, so I think we're ready to answer some examples, and then you guys can work on the homework. So this would be an example of like a multiple choice question that you'll see on Friday. Which relationship is linear? How do you know something's linear? Well, it has to have a what? How do you know something's linear? Constant rate of change. So what are the x's going up by on here? Delta x is a positive 5. What's the y's going up by? Every time? Every time it goes up by plus 9? So is the first one linear? Good. Linear. Now you're smart people, what do you think the next one's going to be? Yeah, nonlinear. How do you know? What's this x going up by? So delta x is 5 every time. Positive 5 is going up 5, up 5, up 5. But look at the delta y. This one is plus 75, but this one was plus, oh my gosh, I don't know, 225? And then what? 225 again? Is it? Oh, sorry, I can't even add. 375? Yeah, 375. And then what? 25 gets you to 7, so 525. So this one was nonlinear. Why is it nonlinear? Because, well, x is going up by 5. It's constant change in x, but it's not constant change in y. That's kind of funny. Constant change. It's like an oxymoron. Constant change. Well, it just means the thing that you change by has to be constant. Up by 5, up by 9. Up by 5, up by 9. That's constant change. Up by 5, up by 75. Up by 5, up by 225. Up by 5, up by 3. That's not constant change. All right. Graph each equation. So for these ones, we're going to use a table of values. And for the first one, where do you got space on this paper? Do you have space at the top at least? A little bit? Okay, you got a little bit of space. We only really need space for I and double I. Okay, so for I, you're going to build a table of values, x and y. What I like to do when I'm trying to sketch a graph from an equation is I like to have some negative input and some positive input. That way I can get some idea of what's happening around the origin. By far the easiest points to check are -1, 0, and 1. I would definitely just check those ones first. We're doing I first. So what happens when the input is 0? That's the easiest thing to do. When the input is 0, y is 25, because 3 times 0 is 0, and then y is 25. The next easiest one to do is when x is 1. What's -3 times 1? -3. -3 plus 25 would be 22. Now why not, just for fun, let's just check x equals 2. We can get this pattern. What happens when x is 2? -3 times 2 is -6 plus 25, 19. What do you notice about this rate of change? It's the x's are going up by 1 and the y's are going down by 3. Just like our equation told us. Remember this equation, y equals mx plus b? This is the equation that you need to absolutely know for this course. Double I is more of a math 20. Double I, it's more for math 20. Anyways, do you think you could figure out what that and that will be without even plugging them into the equation? What will happen when it's -1? You see the pattern? It's going up by 3, is going backwards. And this one should be 31. Want to just check it to make sure? Plug in a -2. -3 times -2, +6. +6 and +25 makes +31. So let's sketch a couple of those points. Let's go up by 5s. What happened when x was 0? 25, right? And we can go horizontally, we can go 0, 1, 2, 3, 4, 5, like this. When x is 1, what is it? 22? Somewhere here. What about when x is 2? 19? So you got a few points there. Now all you need, you guys, is your ID card. And you go like this. And then because this is an equation, it goes on forever. You could always pick a different x value. That's this one here. When it was 0, it was 25. When it was 1, it was 22. When it was 2, it was 19. I plot those points, then I connect with my ID card, like a ruler. Makes a straight line. And then I put the arrows on because I could pick any number for x, couldn't I? X could be any real number. That's why this goes on forever. And is it linear? This is linear. Okay, let's try the next one. This one's going to be a little bit harder. Okay, for double I. Do you see how I chose these x values? Let's just choose those ones again. It gives us a sense of what's going to happen around the origin. More importantly, like 0 and 1 are by far the easiest ones to do. So like what happens when x is 0? 2 times 0 squared is 0. Y equals 5. That's by far the easiest one to do. And we talked about that one. What's that one called again when x is 0? The initial value or the y-intercept. Either of those are perfect. Initial value, y-intercept. It's when x is 0. And what do you notice about what it is in the equation? It's also the constant. The constant is always the y-intercept. The constant. Okay, what happens when x is 1? Remember order of operations. You got to go 1 squared is 1. 1 times 2, 2. 2 plus 5, 7. Okay, plug in a 2. 2 squared, 4. 4 times 2, 8. 8 plus 5, 13. Ask yourself, is this linear? As x goes up by 1, y went up by 2. As x goes up by 1, y went up by 6. Right away you know it's non-linear. You know what's another tip? Look at the equation. What degree is this? Power 2. What degree is the linear one? Power 1. So if you get an equation, look at the degree. Power 1 is linear. So degree 1, linear. Any other degree, non-linear. Okay, let's do the back end of this. Plug in -1. What is -1 squared? -1 squared. I'll write on the board for you guys. I don't know about that. It's +1. Why is it +1? Negative times negative is a... If you put that in your calculator and don't put the brackets in, it'll lie to you. So be smarter than your calculator. Okay, -1 squared is 1. 1 times 2 is 2. 2 plus 5 is 7. Hey, look at that. It's the same value as +1. Let's plug in a -2. -2 squared is 4. 4 times 2 is 8 plus 5 is... Hey, it's the same. Let's graph that one. Okay, let's graph that one. What do these boxes go up to? 10? Okay, let's just treat every box like it's 1. That makes it easy. So when you're 0, you're 5. When you're 1, you're 7. And when you're -1, you're 7. And when you're 2, you're 13. So we got to go 1, 2, 3, 3 extra boxes. And then we can connect that. Do you guys recognize these ones? You've been doing them in the domain and range. This is what the degree 2 polynomial will look like. See these U shapes? It has a special name. You guys don't have to worry about it too much in Math 10 at all. They're called parabolas. And they're studied more in Math 20. Math 20. And they can also go up, they can also go upside down. They can also go sideways. But again, in Math 10, all you would consider that function to be is, all you would say is nonlinear. Nonlinear. You guys okay with that? I mean, there's a lot going on. I think one of the biggest skills you could have is a table of values here. Because if you get any equation, you could always just make a table of values and try to see what the points are doing. This is a great skill to have. Okay? And I always just pick like 0 and 1 because they're really easy. And then if you need more than that, try 2. Go to -1, -2. Just try a few close to 0. Those are easy to input. Okay, now we're going to do the next two. And I put these ones on purposefully because they always trip students up for some reason. Number 3, y equals 5. That's an interesting equation, y equals 5. So no matter what x you pick, you always get 5. So that's 1, 2, 3, 4, 5. This is 5. So no matter what x you pick, you always get 5. That makes a horizontal line that goes on forever. This is the equation y equals 5, and it is linear. So where do you think x equals 1 is? Where's the other one going to be? The next equation, the next graph. Where's x equals 1 going to be? 1 to the right? That would be on that where that dot lies. So it goes this way. And it goes on forever. That's also linear. These two I put there purposefully because if it says y equals 5, students will think, oh, that's a vertical line at 5. Well, no, it's a horizontal line at 5. Even though it says y, it's horizontal. And even though this one says x, it's vertical. Because for no matter what y value you pick, it'll be on x1. Okay. A new car is purchased for 24,000. I would consider that a initial value. Every year, the value of the car decreases by 15%. The value is related to time. So take that initial value of 24,000, and if it decreases by 15%, how much of the car is maintained? You lose 15%, but how much is maintained? 85. So that's what the car is worth in the second year. You see what I did there? You don't times it by 0.15. Let me start that over. Yeah, if you want to times it by 0.15, then that's the number you have to subtract from 24,000. That's the same as if you just did 24,000 times 0.85. Do you guys know your percentages? How much is lost? How much is maintained? So anyways, what's the next value going to be? 20,400 times 0.85. Is it going to go down by the same amount every time? No. Because you're taking percentages of smaller numbers. So you're going to continually have a change that's different. This one's non-linear. Okay, I'll go back to the lesson. And I'll just use my calculator. For A, I'll write some ordered pairs for you. 0, 24,000. The next one would be when you're 1 year later, you'd go 20,000, 24,000 times 0.85 is 20,400. Do the second year, times that 20,400 by 0.85 again, and you get 17,340. So delta x is positive 1, delta y is, you're going to have to subtract those. Get 3,600, negative. And then it happens again, delta x is positive 1, and this time delta y is 3,060, negative. So see how the delta y is not the same? That would be non-linear. And for part B, what do you guys think about part B? $75 flat rate. What would you call that? Initial value. And then it's going to be 50 bucks for every hour he works. So what happens when x is 0? Y is 75. What happens when x is 1? Y is, well, you just have to add 50. 125. What happens when x is 2? Y is 175. So is this one linear? Yeah, this one is linear. Delta x is going up by 1. Delta y is going up by 50. One more to go, guys. Okay, we have a water tank. It can hold up to 6,000 liters of water. They both fill and empty at a constant rate. How does that connect to the graphs? What shape are the graphs? Linear. Do you see how they're not curved? That's the constant rate of change. They're linear. Look at graph A, filling. As time goes on, the volume goes up. On graph B for emptying, as time goes on, the volume decreases. Remember that the independent variable is x, and in this case is time. The dependent variable is y, and in this case is volume. You will definitely be asked that question on quizzes and exams. Identify the independent, identify the dependent. That's a huge outcome. Because when you get to Math 11, Math 12, Science 11, Science 12, you're constantly being bombarded with graphs. And if you can't read graphs and you can't understand what depends on what, you're going to have a terrible time understanding what's going on. Math 10 is really crucial. Okay, part B, determine the rate of change and then describe what it represents. These are basically the quiz questions for tomorrow. These are the quiz questions. So you're going to have to just identify some perfect points. And I'll put the word good. Identify good points. So what do I mean by that? Look at these ones. See these dots? Are those good points? Yes, they are. Connect those dots with an over and an up. We call that one delta x, and we call that one delta y. So for that first one, what's the delta y? How much does it go up by? What's the value right here? Huh? 1,000. What's the value here? 3,000. So what did it go up by? Huh? 2,000. So you go 3,000, take away 1,000. The delta y is 2,000. Okay, because it's like from here to here. What about the delta x from those perfect points? It went from about here to here. So it went from 20 to 60. What's the change from 20 to 60? 40? So you go 60, take away 20 is 40. And then what's important that I'm missing here? Say it louder. Louder? So scared. Louder! Yeah! I just yelled into the mic. People watching the video are just like so mad right now. Yeah. Liters goes on the, which one? Top or bottom? Top. And the bottom is, so it's liters per minute. If you were like a water tank guru and you sold water tanks and you're talking to customers, would you not want to tell them, you know, how much liters per minute they could fill up? This is one of the best water tanks, 2,000 liters in 40 minutes. Okay, and then all you gotta do is divide that number. What's 2,000 divided by 40? About 50? Or exactly 50. 50 liters per minute. That's how you say that. 50 liters per minute. And then what's important here, guys, is that it's actually a positive. I don't have to write it because you don't have to write positives, but I'm going to put it anyway. Because what's this graph doing? Growing as time goes on? Or shrinking as time goes on? Growing. So you have a positive rate of change. What do you think is going to happen for this one? Because it's shrinking as time goes on, it's going to be a negative. Okay, so identify the two perfect points. I'm going to use these two perfect points. That's delta x. That's delta y. Okay, let's do the delta y first. It started at 4,000 and then it became 2,000. So how much did it drop by? 2,000. So delta y would be 2,000 take away 4,000. And in what time interval? From about 20 to 40. From 20 seconds, or pardon me, 20 minutes to 40 minutes, what's that delta x? No, because it's going to be negative. So 40 take away 20. You get negative 2,000 liters in 20 minutes. Negative 2,000 in 20 minutes. Negative 100 liters per minute. And then the most fun part of all this. Describe what it represents. The first one, gain 50 liters every minute. The second one, lose 100 liters every minute. And the homework's at the bottom. There's a lot of questions. And I didn't give you a ton of time. So maybe you want to stick around at East. Try to work on some homework. But if you're looking for like what the quiz is going to look like, it's basically this question here. And my recommendation is like when you're doing these slope calculations, just think about making this triangle. Make this right angle triangle, figure out what the x changes by, figure out what the y changes by, and then divide them. Make sure y goes on top of x. And also think to yourself, is the graph increasing with time or is the graph decreasing with time, positive versus negative?